Okay, here we've got a first order linear DE. We've gone through the template work done previously, so we're going to apply the template now to solve this differential equation. Now the first set of the template indicated that we've got to find dy dx, we've got to get the term with dy dx with no coefficient. So this x cubed can be removed by dividing right through by x cubed. So our first step is to get dy dx not by itself, but just with a coefficient of 1. So my first step is to divide right through by x cubed. And when I divide right through this equation by x cubed, I get dy dx plus, now dividing that by x cubed, I'll have x squared over x cubed, so that'll be just y on x. And I divide this by x cubed here, and I'll get just a 2 plus, and divide that by x cubed, 1 on x cubed. So that was the first step of the template, is to get dy dx with a coefficient of 1. The second step is to calculate the integrating factor, and the integrating factor is I of x is equal to the integral, or e to the integral. Now p of x, y on x can be written as 1 on x times y. So there's my p of x. It's 1 on x. So it'll be the integral of 1 on x dx. Okay, so y on x can be written as 1 on xy. So here is identified what my p of x is. And the integrating factor is e to the integral of p of x dx. So the integral of 1 on x is ln x. So it's e to the ln x. But we know from up here that x has got to be greater than 0, so therefore e to the ln of x is just equal to x. So my integrating factor is simply x. Step number 3 is to multiply both sides by x, and when we multiply both sides by x, up here we get x dy dx plus y, so multiplying this by x, we get y equals 2x plus, multiply this by x, and I get 1 over x squared. Now, the whole idea of the integrating factor is that this is the derivative of uv. So we know that d dx of uv equals uv dash plus u dash v. If you like, here is my u, and this is my v dash, and this has a coefficient here of 1, so that will be u dash will be equal to 1 if you like, and this is my v. So instead of all that, we can say that that is just the derivative with respect to x. This is step number 4, so that'll be d dx of uv, which is just equal to xy. So that is the derivative of xy, just using the product rule, and that's just equal to 2x plus 1 on x squared. Alright, now the next step is to integrate both sides with respect to x, and if I integrate that, the derivative, well, I just get xy equals the integral of 2x plus 1 on x squared dx. Okay, so if I find the derivative, then integrate, I'm back to xy again. That is going to be equal to the integral of 2x will be just equal to x squared. Now, 1 on x squared equals x to the negative 2. When I integrate that, you add a power on the power, so you get minus x to the minus 1, because it'll be add a power, will be x to the minus 1 over negative 1. The negative 1 will make that positive there into a negative, plus c. And this last step is to make y the subject. So we divide right through by x, so we get y equals, now divide that by x, and I'll just get x. Divide that, now that's already 1 over x, and divide that by another x, minus is there, divide by another x, I'll get 1 over x squared, plus divide c by x, I get c over x. Now, there are no initial conditions. This is not an initial condition. It doesn't say what the value of y is when x equals a value. It just is a domain for x. X has to be greater than 0. That came into play when we were actually evaluating down here. So we can't substitute any initial conditions in to find c, so that is a general solution to the differential equation. So going through the 6 steps of the template again, we get the coefficient of dy dx equal to 1. We do that by dividing by, in this case, x cubed, and if we divide there by x cubed, we've got to divide that by x cubed, that by x cubed, that by x cubed, and we got to there. We calculate the integrating factor, whatever the coefficient of y is, so that's 1 on x times y, so p of x must be equal to 1 on x. So the integrating factor is e to the integral of 1 on x dx, 1 on x being p of x, and e to the ln x is just equal to x. We then set up a scenario where we've got the product rule going on the left hand side, and that is done on purpose. That's why we choose I of x to be x. That sets up the product rule. The right hand side doesn't change, and so instead of writing it like that, we can just say d dx of xy. Here we've got a product of 2 functions together. They're u v dash plus u dash v. So we can just write like that. Then we integrate both sides, and we don't want xy as our answer, or the integrating factor times y. We've got to divide right through by x, and we get y equals x minus 1 on x squared plus c on x. Now once again, if you had time in an exam situation, it would be worthwhile finding dy dx here and substituting back in here and making sure that the left hand side, substituting for y, substituting for dy dx there, multiply all that out using this function down here as an answer, and hopefully be equal to 2x cubed plus 1, or else a good way to check to see if you've made a mistake.